Okay. So, okay, we got 2 to the x equals 5. We've got these rules, which I'm not going to tell you. You just got to know them, and you should know why they occur. Because the inverse function, this is the inverse function to this, and you're just switching the columns of the graph. Okay? Now, it's easier to remember if you understand that. You've just got to memorize this. You take a good chance of messing it up. Okay? But whether or not you do, you're responsible for being able to do this, right? I expect you to know this. Because we're going to go a lot more deep. We're going to go a lot deeper after the midterm into these equations. And as I said, they're important. You see many applications. Okay? So, you got 2 to the x equals 5. I'm going to go through the steps. Okay? And make sure you go through the steps. If you skip the steps, you're going to write something down wrong, almost certainly. Okay? So we identify A and C. What's A?
X.
A is what you raise to the power of, right? So A is
X.
X, and C is the thing on the other side of the equal sign is 5. Now it's easy in this case, but when you have more complicated expressions, I see people starting to get confused. Okay? Although people who identified the A's and the C's pretty much did it right. So if you did that, you probably don't need me to tell you now, but let's just do it. Because it's critically important. Okay, so log base 2 of C, which is 5, equals A, which is X. And since we're trying to solve for X, there's your solution, right? Okay? And then I said use the table. Now you can also use the graph, because a graph of log base 2 goes out to 4 for your basic function. You extend it just a little further, and you can kind of estimate it's going to be a little more than 2. Okay? In other words, your log base 2 graph looks like this, and when you got 4 here, you've got 2 here. So it's going to keep going up a little bit. By the time you get to 5, it's going to be a little more than 2, right? You should know that. Because there are other questions I could ask that just ask you to estimate them based on a good graph. And I might not give you a table. I might ask you to make your own table from the graph. And we did that last week. Okay? So you got log base 2 of 5 equals X. So it looks like X is a little more than 2. At the very end of the course, I might well show you what a graphic calculator allows you to do with this. Okay? If I show you now, you'll never understand it, because you just use a graphic calculator by rote, and you won't ever understand what you're seeing. So you're constructing it by hand, but based on the basic functions. And then the calculator can help you reinforce what you know, rather than replacing the act of knowing anything at all. Okay, so log base 2 of 5 equals X. So I can make a sensible estimate of what X ought to be. It ought to be a little more than 2. Now I look at the table. Log base 2 of 5 equals what? I think I looked at this yesterday. It's 2.32 or something like that. And then I don't remember the rest of it. Yeah. Well, there's a pretty accurate solution. Okay? A approximately equal you can round that off to two significant figures, okay? And you can see that that's consistent with what your graph kind of shows you. Okay, well, so the process when you see an exponential or logarithmic equation is identify A, identify C. Okay? If you get something that's compatible with your basic graph of the log or the exponential, then by all means make an estimate. If it involves the extended exponential or extended log, the complete exponential, the complete log function, well, it's pretty easy to transition from the basic function to the complete function, but we haven't done that. Okay, so you might not know how the graph looks, although you might have a good idea. Okay, well, that's the process. Now we're just going to apply it to some of the others, like three times 2 to the x equals 5. Okay? Well, now that's not in this form, or this form, right? But which form is it closer to, this one or this one?
The top one.
Well, let's vote. How many think the top one? How many think the bottom one? How many aren't thinking? How many just too tired to raise their hands? Go ahead. Pretend you're too tired to raise your hands if you didn't understand. Okay? I'll accept it. But on the test, you better be thinking. Okay. It's not. Why is it? Okay, it's closest to this form because you got a 2 to the x, right? Your variable is here. Okay? That's the problem, and you got this thing that allows you to deal with that, but why is this not in this form?
Because there's
Sorry?
there's a 3 being multiplied.
Yeah, you got that 3 in there, right? Well, what are you going to do about that?
Divide
You
it
got a
out.
3 here, and you don't want it. So just erase it, right? And do 2 to the x equals 5. Well, that's not going to work, is it? Okay? But if you draw a line through it, you've canceled it, and then it's gone, right? We don't do cancellation. We do valid mathematical operations. Okay? Unless you can prove to me that you really understand the rules for cancellation. Okay? So, what do we do?
Divide the 3.
Divide both sides by 3. Okay? Make sense? Well, I've seen people try to apply the rule without dividing that. Okay? And identifying that A is x and B is, or C is 5, right? Okay? That's not right. You divide both sides by 3. And I would really prefer if you show me the step where you divide both sides by 3. Don't cancel. I get 3 over 3 times 2 to the x, which is just 1 times 2 to the x and so forth. Okay, so now A equals x, C, we don't want to use B for reasons that you'll see when we come back here and do this with other bases. C equals 5/3. Log base 2 of 5/3 equals x, right? Okay, well, 5/3, we can do this. I mean, here's 1, out here's 4. Okay, 5/3 is 1 2/3, which is about 1.7. So let's see, here's 1, 2, 3, 4. I would say that 5/3 is about here. So we come up to the graph and over. Okay? Now, when x is 2, y is 1. When x is 4, y is 2. There's a scaled graph. You can draw a bigger one, more accurate. Hopefully you're going to draw one bigger. But we just locate 5/3 here. We come up here and estimate, and we see it looks pretty close to 1. Okay? So, I'm saying looks like maybe x is pretty close to 0.7, or even, I think maybe even 0.8. The way I drew it. I didn't draw it very well. Okay? You can draw it better. Now we look on the table. Now 5/3 is between 1.6 and 1.7. We'll do this in order. Five-thirds in decimals, 1.6 repeating. So the log is going to be between the log of 1.6 and 1.7, closer to 1.7. And actually our table only gives us 1.5 and 2, right? Okay, log base 2 of 2 is of course 1. Log base 2 of 1.5 is 0.58.
Sorry about that.
This is a little closer to 1.5 than it is to 2, right? So we figure it's maybe going to be a little closer to 0.58 than 1. Of course, you got the curvature, and I don't expect you to be an expert in dealing with the curvature, right? But you can say that, okay, here is 1.5. Here's 2, here's 1.66, repeating. This one projects over here to a value of 0.58. And this one projects over to a value of 1. So the curve looks kind of like this. So 1.66 looks like it's almost halfway between 0.58 and 1, right? So I would estimate this as .7 or 0.8. Now, if you just show me that you're looking at 1.5 and 2 and say, okay, reason out, put a little sentence down there, we're a little closer to 1.5 than they are to 2, so we figure it's going to be a little closer to 0.58 than 1. Okay, show me you're at least reasoning that out. If you draw this picture fairly well, that's just icing on the cake. Okay, it backs you up in case you make a totally absurd estimate, say it's 15.6 or something like that. Okay, but if you show me the picture, show me the projections, it'll cover you for an error and something else, right? Or if you show me the picture without a good explanation, I'll accept it. Okay? Give me a bad explanation but a good picture, I'll ignore the bad explanation. Okay? Because that's pretty good thinking. Okay, well, we go on and let's just look at one of the others. Where are you? I'll do it up here. Okay? And I'm not gonna use 4, that would be my number. Let's just say it's 7. Okay? Well, how do you solve it? You want to get x, right? You've translated it, and it's real easy to translate. You just identify A as your exponent, B is the other, or C is the other number, right? It's not B, it's C. Just doing the same thing I did over here. The only difference is your exponent is x minus 3 and not just x. Okay? And it might be x squared plus 5x minus 4. Okay? Which would be quadratic. It's going to give you an equation, and log base 2 is just a number. Okay? That's how log base 2 of 7 is just a number. Okay? Well, you're given a table, right? And you can do a graph. Again, your graph turns out, if you go out to 9, you're going to get 0 here, you're going to get 1 here. Sorry, you're going to get 1 here. 2. And you're going to get 2 here. It turns out it's not 9, it's 8. You go up to 3 and you get 8. So you can sketch your graph and you can say, okay, if I'm at 7, I'm almost up to 3, so I can estimate this maybe 2.8. Then we look at the table. We look at 7, we get, oh man, I nailed down 2.807. I didn't realize I was that good. I got a good night's sleep, that must be it. Okay? That was actually just dumb luck. Okay? Not total luck. Because I know how to interpolate even with a curve. But still, I'm proud of myself. Okay? Now that aside, this means that we can write this equation as x minus 3 is approximately equal to 2.8. Can you solve that equation for x? Yeah. Okay? You'd get an approximate value, but it'd be close. Okay? Now, if this exponent had been x squared plus 5x minus 9, what would that have done? Well, you'd have x squared plus 5x minus 9 here equals 2.8. Can you solve that equation? Well, we did last time, just illustrating. If you got x squareds and x's and constant numbers, okay? Then you've got a quadratic equation. You can use a quadratic formula, right? Nothing to it. Okay? You got to keep in mind that these logs are always just numbers. And you can replace it with a number and you can solve the equation. Make sure I got my arithmetic right. I think that's right. Okay, x would be 5.8. Add 3 to both sides. Okay? No mystery to it. You just translate it and take what you get and see if you can solve it. Okay? Makes sense?